essential atoms in your body, every one of them was synthesized in the stars, right? Wow. And all the atoms that make up the Earth and all their properties were synthesized in the stars. So all the properties of the Earth, the crustal rocks of the Earth, was all abundant, and it came out of a supernovae explosion. A time when one star burned for a few days brighter than the whole of our galaxy, right? That's how life is released from the stars, right? That's how it gets to you and me and the solar system, you see. But I mean, I really only mention this because of the beauty of the thing, you see. So.
But what's your background? I'm curious. Where have you come? Who
I'm
are you? Where are you?
I'm a medic for a start.
Where do you live?
Oh, well, I've just retired from full academic life, actually. I'm in New Zealand at the moment,
wow.
But I've got a house in Perth in Australia, so I sort of commute a bit. When it gets cold in New Zealand, I go to Perth. No, I'm a medic. I did a PhD in King's, just after the discovery of the double helix and everything. And then I've been in intensive care medicine. But for the last 20 years, I've been working in human genetics, looking for genes responsible for human disease. And this is an academic interest, I've always had, though. And I wrote a book, you see, Nature's Destiny,
wow.
which was an update of... Henderson was the professor of physiological chemistry at Harvard, right?
Okay. And
when I was in intensive care medicine in Sydney, I came across some of the phenomena that led him to write this book, right? The strange fitness of oxidative metabolism. All our energy comes from oxidation, right? Oxidation, as the professor of chemistry at Harvard says, is the reaction that empowers the world, right?
It's true.
And basically, it's in technology and human life. We live by combustion, right?
Exactly.
Of reduced carbons. But basically, in fact, when you look at I was working in intensive care in Sydney, and basically, when you're doing that work, you realize that, in fact, oxygen has properties, carbon dioxide has properties, water has properties, right? And it all fits together to make possible oxidative metabolism in a being like yourself. For instance, when you lose heat at 38 degrees, you've got to lose it by evaporative cooling of water, right? You see, if you go into a desert at 40 degrees or 43 degrees, you can't radiate the heat out of the body, right?
Mm.
And unless you have evaporative cooling, and water happens to have the greatest evaporative cooling effect of any fluid known, right? That's how you live in the desert, you see. And when I was doing intensive care medicine, I realized what Henderson realized, because he says this himself, because he made massive discoveries in respiratory physiology at the beginning of the 20th century, right? Every medic knows his formula, the Henderson-Hasselbalch, which determines the relationship between pH to your blood and acid base and things like that. And I came to realize that there was a strange fitness in all this for life like ourselves. And then when I went to the Human Gene Mapping Conference in '87 in Paris, and a guy who was in fact a member of the French Academy told me, well, Mike, he said, why don't you read this book by Henderson? He also had some of your ideas as well, you see. So basically, I read Henderson, and then 10 years after I read Henderson, I decided to try and update it. You get it? You see? So, and I updated it, but this is a classic. This is a real classic. Updates are never equal the classic, right? Mm-hmm. This is the first statement. It's like Newton's Principia. Nobody can ever write, even Einstein, you can't do Newton's Principia again, because he found the science. And the modern world, to a large extent, you talk about the pen being mightier than the sword. The modern world is largely the outcome of Principia, that the world runs according to natural laws, and we can discover them, work them out, and can be empowered by this knowledge, right? That was science, right? It changed the whole world. So, nobody can equal Principia. And this is a great classic as well. It's very, very seldom read, but I mean, as I say, I came across phenomena when I was working in my own professional field in intensive.
Literally experienced the phenomena.
Yeah, I literally experienced it. You realize that, in fact, for instance, a thing that tremendously struck Henderson when he was researching in Harvard was that when oxygen combines with reduced carbon, that's CH, right? I mean, reduced carbon, which is Wood's reduced carbon as well. The end product is CO2 and water. Water is the matrix of life. And CO2 has amazing properties, which make it so fit for so many reasons. When it combines with water, it gives you the bicarbonate buffer, which is the major buffering system against acidity in the body, you see. So you see this, the way everything seems to fit together. You'd think that, in fact, the world had been arranged for oxidation in organisms like ourselves, you think.
Well, first off, just so I get to know you particularly, because just in the spirit of this conference, what is, at this point, that you've come to appreciate to be the message that you want to bring? not just on this conference, assuming that there is a life message, if there were a life message, what would you say your message is that you've come to appreciate from all your reading? It doesn't have to necessarily be vitalistic.
No. That the universe, that the universe is essentially, in some mysterious way, biocentric. In other words, the organization of the cosmos is such that life was an inevitable product of the cosmic
Outcome,
order,
right? Had to be.
And so the design of the thing, I don't like to use the word watch in the context of a vitalist conference, but just as all the cogs of a watch fit together towards the end of telling time, so the way that the frequency with which supernovae explode in the sky, right? If it's too frequent, all life in a galaxy is wiped out, right?
Right.
And everything is fine-tuned to get the atoms of life onto a planet like ours, and then to facilitate the coming of life. So in other words, basically, life, the existence of life in the cosmos, and I would say intelligent life like humans, is actually built right into the structure of nature from the very beginning. And I think that's the main take-home lesson of modern science.
How do we bridge modern science with that understanding? It seems to be that understanding kind of lies in the background, not the foreground. And that for me, that seems to be one of the challenges.
Well, the connection, of course, is that you have to now propose mindfulness or intelligence somewhere to account for this, right?
Mm-hmm.
Because the design is so improbable. I mean, a wonderful quote from, Fred Hoyle. Fred Hoyle is here. I mean, he went out to Caltech after World War II, and he's a sort of, hard-talking Yorkshireman from Northern England, and very unkempt, and he went up to Willie Fowler and he said, the only way you can get carbon in the universe is by having certain energy levels, right, in beryllium, the carbon atom, and this is very, very famous for this. It's the major discovery probably in 20th century physics, actually. He said, you have to have these energy levels, and Willie Fowler said they're wildly improbable, they couldn't exist in nature. But then, of course, he sneaked down to the atom smasher at Caltech. They had one there, you see. And they did the experiments, he suggested, right, and he staggered them all. Because here was this sort of unkempt, sort of, irreverent figure.
Mm-hmm.
Hard atheist then he was, of course.
Wow.
Yeah. Made a prediction of staggering consequence, and they wrote a famous paper, and they all got the Nobel Prize from the paper, right? When they predicted these wildly improbable energy levels. And that day that they discovered it down underground in the Caltech atom smasher, Hoyle went from atheist to theist.
Wow.
Because he couldn't believe it. He said it's so improbable that these relationships exist, which mean that the building of atoms can go beyond beryllium to carbon, oxygen, nitrogen, and so forth. You see. This is, I think, a coded message almost. This is the cosmic abundance of the elements in the cosmos, right? Now remember that the chain of coincidence, the chain of things you have to get atoms is incredible. You've got to have 10 million degrees in the center of stars, you've got to have supernovae to get them out of the star, right? You've got to have a whole lot of conditions correct in the cosmos to get the atoms of life out. These are the main atoms of life: hydrogen, oxygen, carbon, nitrogen, magnesium, which is the metal in chlorophyll, and iron is a very important metal. It handles oxygen. It handles oxygen in the body, in your body, hemoglobin. It carries it around the body. Silicon is one of the major constituents of the Earth's crust, and of course water and CO2 are the two key molecules. All the carbon in the world is built up from carbon dioxide, right, in every organism. Right? Now just look at this. The commonest atom in your body is hydrogen. It's the commonest in the cosmos, right? The second commonest reactive atom, helium is an inert gas like neon and argon and krypton. Right? The second most reactive atom is oxygen, and it's the second most common atom in your body. Right? The third most atom common in your is carbon, and it's the third most abundant in the cosmos, right? It goes on like this. Nitrogen, the fourth most abundant.
Someone supports that as above, so below.
Well, people say, can I have a message from the gods, you see?
It's like a hint. It's a map.
Now, not only it's a hint, it's a strong hint. It's
a real strong hint.
And this is right at the heart of the hardest of science, right? This is not something esoteric, it's not New Age, it's absolutely hard science, right? This is the measurement of the cosmic abundance of the elements of life throughout the cosmos, and the fantastic story of how they're made, right? Now basically, the other thing about it is that in fact water, which is the matrix of life, and also your 70% of your body is water, H-O. CO2, CO. They're there as well, the molecules are there as well. And guess how much water there is in our galaxy? 200 million solar masses of water. 200 million solar masses of water in interstellar space in our galaxy alone, right? The cosmos is flooded with the seeds of life. Now, if it was the case that you could make life with all sorts of other atoms, right, it wouldn't be so significant. But these atoms are uniquely fit together. In fact, I mean, it's organic chemistry, really, isn't it? It's the carbon atom is an amazing atom because it links with itself and it can forms vast majority of all compounds known to science, known to chemistry, are organic chemicals, right? And so basically, it's not that these compounds are the most common. Not only are they the most common, but they're uniquely endowed to make life as well, you see. So it's not just that life had to use those atoms. They're the only atoms it could use, and they're the commonest in the cosmos, you see. So this is a powerful coded message. And I like to think of it as a reversal of the starry messenger of Galileo. He wrote this famous book. He looked through his telescope, and I mean, earlier in the talk we're talking about the collapse of the old teleological vitalist view, you see. So I mean, but then he looked into the sky and he saw the universe seem to extend forever. Each time he built a more powerful telescope, he could see further and further into the cosmos. He saw that in fact Jupiter was a little solar system, like the sun's system. And he immediately started to suggest, of course, in the starry messenger, the messenger that came from the skies was that humans had no central place in nature. Well, the message that comes from 20th century cosmology and physics is that life has a very central place in nature, you see. And the Murchison meteor, which hit that Australian town in 1969, which is one of the most important sidereal messengers of the 20th century, as well as this, brought carbon, the nitrogenous bases of DNA to the Earth from space. And it was the first one that people got clean, right? You know, there's no contamination on it, right? And what the Murchison meteor said is, throughout the universe are all the building blocks of life. Not just the atoms of life, but the basic compounds as well, they're out there as well. So this was a message. So that Galileo's pessimism and nihilism, that there was no purpose in the world related to life or man, was now reversed beautifully by the discoveries of Hoyle and his colleagues, and basically, you know, in 20th century physics.
Question: do you think from this that you can deduct? Is it wise to believe then that we can sort of assimilate some sort of meaning or purpose to our life, or is that just egoic?
Well, basically, these are discoveries ongoing. You know, it's the scientific endeavor is ongoing, and where it's going to lead exactly, I don't know. And what relation did all that it says to the individual, I suppose, is that in fact, when people like Stephen Gould say that in fact, you know, we are an improbable twig on the edge of an evolutionary tree generated by chance and all that sort of thing, right? At least this is countering that thrust, right? You see? And it certainly suggests that in fact, it points to the old cosmos of the pre-scientific age, right, where humans and individual humans, you know, I mean, they used to read horoscopes, right? You know? Astrology is another example of that pre-scientific idea that we fit into the universe and we have some relationship with its overall structure and things. So as far as the individual is concerned, all the individual can get from this, I suppose, is that the movement of modern science is back towards the ancient teleological view of the world. So it's very, very, so I mean, it's quite exciting.
But again, what I feel like I want to glean from you, the wisdom that I want to glean from you, because you seem to have synthesized quite a lot. You come from a strongly scientific background, and you're passionate about the relationship here of these beautiful atoms and how they're, you know, in nature, in the universe, and in the body. So do you believe then, again, because we assign a significance to our life for whatever reason, is that a foolish practice?
I don't think it's, I thought, when I first started my scientific career, I started off as a Christian fundamentalist, and then I left the whole thing when I went to medical school, because, you know, the human body has some design flaws in it and all sorts of things, and I realized that man was out of Africa, and, you know, we were a primate and this sort of thing. But lately, in the last 20 years, no, I think that in fact we should be careful about writing ourselves off, you know. We should be very cautious before we dismiss the possibility that the cosmos is manifesting some moral, intellectual, some sort of purpose. Yeah, I think it is now. manifesting something like that. I think that's where it's going.
My understanding is that evolution is happening in spite of us. Even though we're part of it, it doesn't seem like it really requires. I mean, we came from something before we had this level of consciousness, if you want to call it, or understanding. But how did we show this sort of entropy, if you will, or this, progression? How did we get here, and where are we going? I mean, there seems to be some form of
I would say that
directionality.
This line of evidence definitely supports that idea that we're going to discover more directionality, more intelligent causation in the nature of things, right?
Right.
And it might come right down to individuals and everything else. I mean, it's it looks to me as if the whole process of the disassembling of the pre-scientific worldview, the anima mundi,
right,
sort of the Sistine Chapel, all
exactly.
those ideas, which were disassembled by science. It looks to me as if it's starting to move back to those sort of ideas again.
Right. I think for me personally, when I get into astronomy and I see how small we are, when you said stardust, that's why I started this recording. I'd love for you to elaborate a little bit on that. Yeah. I really would. I'm very curious about that. I believe, for me personally, that there's got to be some form of understanding that we, like I said, glean. That's why I love to ask questions. I want to glean some kind of wisdom. I believe we all bring a contribution. Yes. Obviously, because we're so different, there's different gifts we have genetically and whatever we're bringing. And so I want to learn and yet still maintain a certain platform of intelligence, as well. So how do you, this Stardust piece, I mean, can you elaborate a little bit more on that? Just because I found that quite fascinating. Almost poetic, I got to be honest with you.
It's very poetic, yeah. In the talk, actually, I've got a slide where I show the Aboriginals in Australia. They used to believe that, in fact, they looked up at the stars at night, and of course in the outback it's very clear nights, right, because it's very dry climate and so forth. There's Milky Ways right across the sky and everything. And they used to say that the bright stars are the campfires of the ancestors who recently departed, and the dim stars are those that went earlier, right? It's a beautiful thing. It's an absolutely beautiful thing in the dream time, right? It's a far more wonderful thing, of course.
That's very mythical.
It's wonderful, yeah. And basically, of course, what modern science has shown is that the Aboriginal sort of idea is not, it's not exactly correct, but there's it's much closer to the truth than most of the scientific ideas from 1600 to 1900.
Wow.
You see what I mean? Mm-hmm. Because there is a connection between those Aboriginals and those lights in the sky, a deep connection. They need those lights in the sky now. They need them just as they are.
That's perfect.
It's wonderful.
Because, why? They're hints.
Sorry?
They're hints.
Well, they're strong hints.
They're strong. It's strong.
Very strong hints. The whole thing, yeah.
No, and I think when we start appreciating the hints that are in nature, you know.
Have you seen that? I'll show you the Hoyle quote, actually, which is in fact one of the interesting. Hoyle says this about the cosmos, and where does he? No, I don't get it. Let's see. I know this thing off by heart now. Yeah. This is his full quote. The energy levels needed in order to produce carbon in large quantities are statistically very unlikely, and so are all the other conditions which must be right. Hoyle later wrote, "Would you not say to yourself, some super-calculating intellect must have designed the properties of the carbon atom? Otherwise, the chance of finding such an atom through the blind forces of nature would be utterly minuscule. Of course you would. Common sense interpretation of the fact suggests that a super-intellect has monkeyed with physics as well as with chemistry and biology, and there are no blind forces worth speaking about in nature." Think of the stature of this guy.
That's wonderful.
Right? The numbers one calculates from the facts seem to me so overwhelming as to put this question almost beyond question. So you've got to remember, this is the Plumian professor of astronomy at Cambridge University. A very controversial figure, of course, Hoyle. In some ways, and pretty eccentric. Anyway, basically, that's a beautiful quote.
It is. It really is.
And then, of course, there's other things. There's another quote from Paul Davis, who I know I've met a few times at conferences, actually. Recent discoveries about the primeval cosmos oblige us to accept that the expanding universe has been set up within a corporation of astonishing precision. The impression of design is overwhelming. Or what about Penrose's famous Penrose? He's another physicist at Cambridge, actually. This tells us how precise the Creator's aim must be. Must have been, namely to an accuracy of 1 part in 10 to the 123. This is an extraordinary figure. One could not possibly, you know
right.
what a big figure is anyway. And in other words, basically what he's saying is that the fine-tuning of the universe, to have stars and planets and a world which is not chaotic, you have to get everything right, like that. That's why Hoyle makes that statement. But,
you already blew the mind. You didn't need 123 zeros.
Yeah.
You far exceeded the limit of the mind to conceive.
Oh, you can't conceive it.
You can't.
But you can't conceive anything in this realm. It's amazing. I mean, for instance, once some time ago, I was in West Australia. There's some very primitive algae in West Australia called stromolites. They make little rocks in the sea coast, right, in the hot, salty sort of intertidal zone, right. And you can stand there and you can watch the tide coming in over them today, right? And you can go a few miles out and there's some fossil stromolites, right? And they've been dated at about 3.8 billion years, right? 3.8 billion years. That's a substantial fraction of the entire time the cosmos has been here, right? And it's amazing to think that the seas of the Earth and the temperature of the Earth has remained within a pretty narrow band for nearly 4 billion years. The oceans have washed against the shores for 4 billion years. This is engineering.
Yeah.
This is engineering. You think of how difficult it is to keep your house going for 20 years. Right?
Exactly.
Fancy keeping the temperature. Fancy keeping oceans and salts and seas constant for 4.
Well, that's how you know that there is a two-way communication system. So how are you going to maintain this delicate balance? We know in the nervous system there's an afferent and efferent system in the body that maintains itself in existence.
Yes.
So there has to be a two-way communication system somehow operating to maintain what you just said.
Well, yes, basically, of course, this is why James Lovelock proposed the Gaia hypothesis, that the Earth is a living entity, which corrects itself.
It has to be.
I'm nearly convinced by this, but you know what I mean? Yes,
right.
I agree. I mean,
well, it has a resonance. They already know it has a wavelength, so it has a wavelength. It's obviously
Yeah.
alive if you can measure it. It has.
Well, yeah, I mean, Lovelock was, in fact, one of the leading NASA climatologists, right? And he planned the sort of, the Viking thing to Mars and all this sort of stuff. But then he was walking along the shores of his native island one day, looking out to the Atlantic Ocean, and he suddenly had the idea that the Earth is a living organism, right? This is the ancient Greek conception of Gaia, the mother goddess, or the anima mundi, the same sort of thing, right? It's a vitalist idea, that, of course, that the Earth is alive. And he suddenly thought that the only way you could explain the constancy of things was, by presuming that the Earth is alive and regulating itself. And so that was James Lovelock.
Well, let me share with you why I'm glad I'm recording this for a lot of reasons. Number one, with your background, your scientific background, I think what the camera is capturing, and anybody who gets to know, is lucky enough to know you, sees the level of your deep peace. And I mean that. I mean, you have obviously figured things out. Now, this is from a person who doesn't have the capacity to assimilate knowledge the way you do. I don't have.
Well,
I really don't. Maybe I might have the potential to.
Everybody has the same potentials, I think.
I agree. I agree.
I don't think there's much difference.
But I would say the way whatever you want to call it, vitalistic, the way the forces have used me, it's not the same affinity to take on information at this point the way it has been for you, and yet. With all that you carry around, the amount of sure rote information that you know of just knowledge, you have found such a deep peace. And so you have obviously figured something out. You have synthesized something. There is something that makes sense to you, not just to your intellect, to your cognitive mind, but to your spiritual essence, to your being. What is that? What is that?
Well,
it comes across.
It's certainly, first of all, I think that in fact, there are many other arguments in addition to this, and I'm going to mention some of them later. There's the beauty of mathematics, right? Natural law is written, and this is very mysterious, it's written in a mathematical form, right? Now, mathematics, the great question about mathematics is mathematics a human invention, or is it present in nature itself, right? Well, as I show on this talk, actually, if you look at Pascal's triangle and many other things, you find that, in fact, basically there's so many peculiar patterns in the mathematical world, right, which humans clearly didn't invent, that mathematics and the structure of reality that it builds must be it must be present in reality itself before you look at it. And so you've got this fantastic thing, mathematics, right, out there. All the laws of nature, inverse square law, are beautiful, simple, and obey the laws of mathematics, right?
But do the two parallel lines ever cross?
Well, I think they do, because in fact they cross certainly in human cognition and our sense of beauty. We can see that this mathematical fabric is beautiful, and we can see, and not only is it beautiful, but it determines the nature of things. So all these coincidences and all this fine-tuning, right, are arriving from a mathematical basis as well.
If you really believe that these two parallel lines cross, then you're okay with the fact that it's been proposed that if they cross, then all the mathematical laws that we know it are invalid. Or do you disagree with that conclusion?
All the mathematical laws we know are invalid. You'll have to explain that more fully.
Well, the way it was explained to me is that the mathematical laws, the way we know them, the way we promote them, are based on the assumption that two parallel lines never cross. And that...
Oh, yeah, I see. This is Euclidean geometry.
Apparently.
Yeah, but there's higher geometries now in which lines do cross. So, you know, I mean, there's all sorts of different levels of geometry, right? There's geometry of curved space, right? And obviously the geometry of curved space you can set to Euclid. If a line goes on, it goes on forever, and the direction never changes, right?
Exactly.
But a line on the surface of a sphere, you know, can come back to where it started, right? So, I mean, the thing is, there's higher geometry.
In which case, is it straight, though?
Well,
isn't there an arc? Doesn't there have to be an arc if it comes back?
Yeah. And so basically, Euclidean geometry is geometry restricted by certain rules and restrictions, right? And it's restricted to plane surfaces, right?
Mm-hmm.
Whereas, in fact, the cosmos in many ways is curved. It's a curved structure. I mean, in one sense, it's many other things as well. I mean, there's other dimensions of space and time, right? You see. So yes, there's different geometries now. Just as there's different. I mean, there's all sorts of strange forms of numbers. I mean, the first numbers are natural numbers. Then they discovered, you know, irrational numbers, and then they invented imaginary numbers, right? And you know, the story of numbers is absolutely extraordinary. It's the same as the geometries, right? First of all, the mathematicians played with all sorts of ridiculous things, like the square root of -1, which can't exist. They played with all these strange things. But then they found, with the development of quantum mechanics, that amazingly, certain laws, writing down certain laws, just like inverse square law, which is a very simple one, right? You know, gravitational attraction is proportional to 1 over d squared, right? They found that in describing quantum behavior of matter at quantum level, you had to use things like the square root of -1 in the formula, right? Mm. That I find, again, like these cosmic abundance is spooky. What force conceivable apart from an intelligence could have structured nature with the square root of -1 in? Think about it.
I hear you.
What conceivable way could the universe be like that? I mean,
and that's where I would say it's intelligent. You have to believe because
yeah, I agree.
It's way too sophisticated, and that's not even that doesn't even capture it.
It's these facts are really, there's a few facts now in modern science which are absolutely stunning.
Great question I have for you then. What was your most recent aha moment? Because, you know, where you just drop into that deeper piece where things just clicked, where all of a sudden you felt like you were able to synthesize.
Well, I think it was looking at a fractal pattern in Pascal's triangle. Do you know what Pascal's triangle is?
I'm very familiar. Yeah.
Yeah, you are right. Yeah. Well, there's a fractal pattern there. All sorts of fractal patterns in the actual triangle itself.
When did that happen?
It happened a few weeks ago, and I was.
Can you explain it?
When I was preparing that talk. Well, yeah, I mean, basically, I was wondering really to some extent what clear evidence you could find to show that, you know, mathematics was something which men had discovered. As Penrose describes it, you know, he describes it, mathematics, you see mathematical truths in Plato's eternal realm.
I can understand.
You know what I mean?
Yeah, I do.
In other words, it's not that, in fact, we invented that proof, or, you know, a great mathematician sort of...
It's self-sustaining.
Yeah, it's in there straight away.
I understand.
And of course, in his book, The Road to Reality, which is one of a real classic, I would say.
Who wrote that?
Penrose, Roger Penrose in Cambridge, actually, called The Road to Reality. he spends the first few chapters sort of defending his Platonism, that there is an eternal realm of mathematical truth which transcends everything, and mathematicians discover it, right? And I was interested in that, but for me it was just looking at the fractal pattern in Pascal's triangle. I think it's of odd numbers. It's the way the odd numbers make a beautiful set of triangles, and that I thought was absolutely amazing because nobody could have invented that.
Exactly.
Nobody.
Exactly.
I mean, I'm not a mathematician, not remotely like Fred Hoyle or Penrose, right? But on the other hand, I can see that very clearly. I'm going to present it this afternoon.
Beautiful.
Which proves clearly that mathematics is not a human invention, and therefore that in fact there's something out there.
It's a human discovery.
Discovery.
That actually relates to the evolution of humanity, if you will. As we evolve and our understanding continues to grow,
We discovered.
doesn't our observations become also more mature, if you want to call it that? Wouldn't you say
Yes,
that over
certainly,
time,
yes.
right? Isn't that what happened?
Yes.
So isn't our job as human beings, if we really do want to assist nature, it seems to be going in this entropic position, to mature up our understanding of things, to always be in a process of discovery?
Yes.
Wouldn't that also help usher in the new?
It may well do. I mean, as I say, obviously you're thinking about things in different ways to me.
I have patience, that's why. I'm looking everything through the filter
Yeah.
of how can I best serve the people that come to me.
Yeah.
So I love to work with intention, to find out what do you want to move toward. You know, what has the universe set in motion for you, life's your own makeup. What's going to help you be as most present in this moment as you can to support evolution, to support your own growth, your own development, and to be proactive in that movement, rather than reactive, or rather than move away from to move toward, rather than moving away from pain, move toward peace, anything. So I'm always looking as a healer, as a facilitator, as a healthcare practitioner, on what I can do to help people participate more in their own well-being. So I am coming in with such a huge prejudice, even while I'm talking to you. I cannot divorce myself from those eyes. I am committed to this. I'm so devoted to this.
Right. Yeah.
You know, this is between me and whatever, right? And you know that even as you're speaking, I can only hear through a filter. I would love to divorce myself from that filter, but I haven't figured that out yet.
Okay. No. That's fine actually. Yeah. So basically, I mean, it's an ongoing thing.
It is.
And it's exciting to be alive, and it's exciting to experienced what's going on. It's incredible. There was a guy from the Los Alamos laboratory interviewed on New Zealand radio. I just happened to be driving through New Zealand and stick them on actually. And I mean, he said that in fact, you know, that he sort of was suggesting that the theories of modern physics, you know, are and it's a pity that we can't experience it. He said they're some of the most beautiful things that have ever been touched by humans. Right? They're so beautiful. And you know, Bertrand Russell said that mathematics has a beauty which, in fact, transcends man. You see, and I was very touched by that. I think it was an amazing thing to say, actually. You know,
and let me share something. I think our interchange right here is beautiful. I'm serious.
Oh yeah.
I think, and what's amazing is that it can be captured,
yes.
And you will see this incredible energy, if you want to call it that. I mean, that's why I'm choosing to speak with you, because you obviously have something worth sharing. You have a message, and I'm trying to glean that.
I'm an absolute enthusiast about the beauty, the coherence, and the sort of I hate using the word, but I think I should use it, the synchronicity of everything, how it all fits together. And the only thing that, in fact, at the moment makes me slightly reserved about accepting a fully vitalist thing, and that is autonomous agency in nature, as we were talking about earlier, is that in fact I would like to see it backed up with more secure scientific evidence, right?
Let me share with you one of my biggest challenges, what I see.
Yeah.
I think that you're having to back it up scientifically. You have to play by their rules, the scientific rules. You have to fit in a certain scientific protocol. Once you do that, that limiting, if you will, adherence, it does something. It affects the outcome. It affects what's measurable. It affects what's observable, because you're trying so much to satisfy criteria, which in and of itself is designed to study, but from a limited perspective, a limited point of view. It's not as objective as theoretically you would like to believe. So when you're trying to prove something scientifically, what you're saying is take something that's as infinite, look at what you're working on, look at that number that you used, and put it in more of a finite container, because you have to meet these protocols in order for it to be valid, in order, whether it's double blind, triple blind, whatever it is that you have to do, there are certain criteria that you have to meet to make it valid. If you don't meet those, then it's considered invalid scientifically. So now we have an option. We can either put it in that container, in which case we've changed it. We're not really observing it anymore. Or we can let it be and just kind of say it's vitalism. You understand? Because this way we get to experience the full force of it.
Yeah, well, certainly, I mean, I think that there is autonomous agency, right? And but my optimism is this, that in fact, basically, there will come somebody, who, you know, like Newton, another Newton, who will synthesize, generate a new synthesis, which not only chiropractic people will accept, but everybody will accept. And that will be some new view which will carry us forward into a new sort of synthesis. And I think that will happen, but at the moment I'm still perhaps more in love with science than you are, you see.
Right.
You know what I mean? And
no, I understand. Yeah. I want you to, but it's great to have this dialogue.
Oh, sure.
Because I want to be...
I'm certainly not saying that, in fact, the scientific paradigm and the scientific methodology is the only thing, right? That's true. And in fact, basically, what you're saying is it can't be, because we're subjective beings, we've got consciousness, we've got sentience.
Right.
And that doesn't fit into science. So there's something that doesn't fit anywhere.
We can't measure this, but somebody who's observing this on the video is going to say, something is happening. There is something in this interchange that's happening. I'm not sure if that's really measurable.
No,
I'm not sure if it's reproducible.
Yeah. Well, I don't think sentience and consciousness will ever be reduced to a mechanical worldview, right?
Right.
But they might be reduced to a scientific view, but it'll be a futuristic one, which is different to modern science.
Right.
Okay, you know, that's where I'm at the moment. I think there will be an explanation for sentience and consciousness.
Right,
and
I agree.
Yeah, there will be an explanation, and once it's there, it'll be universally acceptable. You know, but it'll be reconcilable with all our scientific knowledge, with all this stuff I'm talking about, right?
Right.
But at the moment, I don't see it at the moment, and yet I accept what you're saying, that in fact there is autonomous agency, there is consciousness and sentience, and these things are not explicable by science, right?
Let me offer a solution. For instance, I see synthesis in you. That's why I'm saying here's a gentleman who's of science, has figured things out. Now, I'm not just being polite. I am not just being polite, because I am recognizing something, and there is a deep piece, and I'm not the only one that would say that, because now you're actually captured on video. So there is some form of cohesiveness, coherence, if you want to call it, deep agreement, that I can see the symptoms, the parameters, if you will, of synthesis. I mean, of deeper understanding. My job now is to help you bring that out. So that's why I'm asking questions, to see maybe you can be part of this just by having this dialogue. To, you know, me asking questions, sort of like, you know, what is your last aha? Help us understand what you've put together that's causing this physiological, neurological thing that I am able to observe in you, that I know is going on inside your body, which is conducive to great health, by the way. So, you understand? So,
that's actually true. I mean, the best run to do is when you're on a high, an academic high.
Right.
Intellectual highs are the greatest sporting thing you could imagine. You know?
And what happens to your body when you're riding those highs? Think about that. I mean, is there a better glass of water? Think about what you're getting in your tissue cells. This kind of conversation, this dialogue.
Yeah, it's very true. I mean, I know that intellectual highs can give you almost unlimited energy.
Absolutely.
I mean, it's a miracle. It comes from somewhere you don't know, you don't understand. But there again, I'm accepting that there is a vital element of consciousness, of sentience, of this thing we're talking about, the intellectual energy that empowers the body and all sort of thing.